All right, so we're going to be going over 1.10, which is about arithmetic sequences. And the directions for this goes here. Use the given information to create the other representations for each arithmetic sequence. So again, arithmetic sequence is it's another name. It's a type of linear function where we just give you numbers, and it's a sequence, so it's a list of numbers. It's not like now that you understand the idea of discrete, it is a discrete function, right? So the very first thing they tell you to do is here's the recursive equation, and then here's f of 1 equals 3 and f of n equals f of n minus 1 plus 4. So just as review, this is telling you my first point I'm going to give you is 1, 3. In order to find the next number, you take the previous number and then you add 4 to it. So this creates just a table for me in my head, and you guys all know how much I love table. So I'm gonna make a little table that looks like this maybe, and I'm just gonna squeeze it over here just so that I have more room. So the very first thing I'm gonna do is I'm gonna fill out this table according to what this says. So here's n, here's f of n. Another way to name them, this is x, this is y, but they've already started using those terms, so I'm gonna continue. And then the first term they give you is 1. So I put a 1 here. The y that they gave me for that is 3. F of 1 is 3. Another way of saying this in regular terms is when x is 1, y is 3. So then this becomes my first term. And then here, I'm just going to fill out the rest of these numbers here. So 2, 3, 4, 5. And then on the bottom, I'm going to put n, so that I can write actually the explicit equation. So recursive equations has 2 parts, your first starting point and how to get to the next point. Your explicit equation is the equation that you guys are used to seeing, and it just stands on its own. It's just one part. So in this land here, because we're in arithmetic land, we're going to be using y equals mx plus b. And all I have to do is find my m and find my b, and then I'm done. Okay, so I'm going to be filling out my table. So it says to get to the next guy, take the previous guy and add 4 to it. So here's my previous guy. So you just want me to add 4 to it, Miss Johnson? Yes. Okay, and then I'm going to add 4 again, and then I'm going to add 4 again, and then I'm going to add 4 again, right? And that's going to be creating my equation down here. Okay, so if you wanted to, you can write this as the number 7. You guys know that I tend to write these out as in a almost kind of like a function. So here I could write 7, but I'm not going to. I'm going to write 3 plus 4. This 3 plus this 4. Okay, and let's just highlight where I got my 4 from. This is this 4 here, came from here, it came from here. Okay, these 4s you should know are called our rate of change, our slope, there's a bunch of names for them. So you should know that, oh, Ms. Johnson, you said that we had to find our slope. Yes. So I can put it in there right now? Yes. Okay, so y equals blank x plus blank. Okay, this 4 goes right there. Remember, we call him the star of the show. He's kind of the one that shows up over and over and over and over and over and over and over again, right? So again, I'm just going to continue. And then I'm going to write that 3. And then this time I'm going to write plus 2 times 4, right? Because it would be 3 plus 4 plus 4. And a faster way of saying 4 plus 4 is 2 times 4. And then I would continue and I would write 3 plus 3 4s, right? And then 3 plus 4 4s. And then I put a 3 here. And then I'm just now seeing, oh, I see my pattern, right? I kind of see my pattern right there. Yes, very good. You see your pattern. So there's my M. And then now I need to go backwards, right? Your B. Remembering that your B is just your y-intercepts. It's when x equals to 0. And you're like, oh, okay, that's all I need, Ms. Johnson, is when x is equal to 0, or in this case, n is equal to 0. Oh man, Ms. Johnson, there's no 0. Okay, so then I'm going to reference my buddy. He always says, Ms. Johnson, just go backwards to get to 0. So I'm going to go backwards from 3, right? I'm going to say what plus 4. So what number plus 4 gives me my 3? And some of you are like, -1. And that's exactly correct. And so that -1 goes over here. Okay, right there. 4x plus 1 or 4n plus -1. So there's my equation. Okay. And then to graph it, you should know you should not be connecting the dots because it's an arithmetic sequence. So it's almost like, let's do your best, Miss Johnson, to graph this. So when I plug in 1, I get there. Okay. So I have my axes here. And then I'm just going to plot these points. So 0, -1. And then I've got 1, 3, and I'll use the rest in kind of like this color. 1, 3, 2, 7, 3, 11. So this is actually my graph. Ms. Johnson, how come you can't connect the dots? Technically you can if you were graphing this thing by itself, right? But because they originally told us it's an arithmetic sequence, think about a sequence as a list, a grocery list, kind of like, all right, I need you to get a -1, a 3, a 7, an 11, and so on. So those numbers are not connected. Notice, because here we didn't put 1.5, right? Remember we had talked about our domain. Our domain doesn't include all the in-betweeners, right? So there's my picture, there's my graph. And then the last thing they said is create a context. Okay, so context is a story problem that represents this. It's my favorite context. My son was doing this when he was in kindergarten, and it was some like subtraction problem. And it was like, I don't know, 8 minus 5 equals to 3. And he goes, there were 8 ants. 5 of them got dead. How many are still around? So you just come up with a simple context like that, and then that's it. So the thing that I know about a context is it has to match my function, it has to match this, and it has to kind of make sense. So so somehow you start with -1, and then something happens and it's 4 every whatever. So the simplest context I can come up with a negative value. Negative values really make me think about money. They also make me think about like sea level, below sea level kind of thing. I'm just going to go with money because money makes the most sense for me right now. So I'm going to type because I type faster than I write. So let's see. I would say something like, you owe me $1. You decide to start saving money every week. You save $4 per week. Create, and then that's it. So then, you don't actually have to come up with a question. They just want you to come up with the context. So you owe me $1, that's that -1. So let's highlight things so that you see where they're coming from. So let's see, this guy here, this -1 is you owe me $1. This -1 is you owe me $1. And then you save $4 per week. That's your slope. So that goes there. Okay. So that's pretty much it in terms of that. Things that you should know is you should be comfortable with reading the recursive function. If you're not comfortable, just practice, because that's the only way that you're going to get better at it. I really like building tables because it's a very like clean way to look at what I'm dealing with. You're going to be finding the rate of change. In fact, right now, my integrated 3 students are talking about rates of change. So this doesn't go away. If you're thinking, okay, I just need to learn this right now. This is actually the most useful application, or one of the most useful applications of what you're learning outside of, math class. So you're doing lots of things with this, and there's tons of things that you can think about. Money saving per week. You can think about, let's see what, like when you go to the store and you're buying, I don't know, candies, or you're buying something and it's, $4 per thing. Lots of different contexts there. Okay, so here, number 7, they asked you to do the same thing. You have to come up with all these things here. And the thing that they gave me first is my equation, is my table, which is my favorite. So the very first thing that I start doing with my table is always finding the rate of change. So again, I'm going to be subtracting. So this is 7, this is 7, and this is 7. No big surprise there. You should all know, oh, Ms. Johnson, that is your slope. So he's going to show up over and over and over again. So let's see where he actually shows up in our recursive and our explicit. So then we understand what we're going to be doing. So where do you see our slope, our rate of change in your recursive equation? Do you see it? Yeah, you're like, oh, it's right here. I kind of feel like Dora right now when I pretend to wait for you guys to answer. That's funny. Okay, so yes. So right here, it is just that +4. So you can imagine me writing the recursive equation for our next problem, and it's just going to be, whatever, +7. Yeah, +7. Okay, so that's there. Where else do you see our slope in our explicit equation? You're like, oh, it's right there. It's at 4. So notice here, I'm going to go down there and I'm going to draw all the structures in, and then I'm going to fill in my slope or whatever that I need to fill in. So in general, my recursive equation is always going to look like this. F of 1 equals something. And then F of n equals F of n minus 1 plus something. My explicit equation is going to be y equals mx plus b, or y equals blank x plus blank. And then again, if you want to use your n's and stuff, you can. I don't know why I switched from n to x. I just noticed that. I think this is what you guys are all used to seeing, so we'll be comfortable with that. And then I now want to fill in where everything goes. Okay, so I know that my 7 goes at the end over here, right? And right here for my m. So here and here, this is where my rate of change goes. This is where my rate of change goes, my slope, whatever you want to call it. So I'm going to put that in there. So this is +7 and this is 7x, right? Okay, so now I got to find the other things. So if you remember, f of 1 is just what is y when x is 1. So here, what is y when x is 1? Oh, that's 2. So you just want me to put a 2 there, Ms. Johnson? I'll put that 2 and I'll put it right here so you guys all can see it. Very good. Okay, and then I say, okay, well, how do I find my y-intercept? And then I say, wait, what did she say y-intercept was? Oh, y-intercept was when x is equal to 0. And then you always tell us to go backwards, Ms. Johnson. Just go backwards to -1. So let me go backwards. Let's do that. So I'm just going to squeeze in a 0 up here. So then I think, oh, I just need to go backwards. So I say, what's +7? So what +7 gives me my 2? And you're like, oh, that must be -5. And you're right. And so I put -5 here. And then I'll just, what color? I think I used blue before. So that number goes there, right? Okay, so I'm pretty much done. I have my recursive, I have my explicit. You guys can graph this on your own. Just, again, don't connect the dots because you'll see why it doesn't make sense, especially for this one. It says, now here's the interesting part. I started with 0 up here. Now I'm kind of thinking I shouldn't have started with 0, but that's okay. So another context you could also do is, you owe me, you don't owe me anything. You have $3 and then you start saving $4 per week, right? But then these numbers would be kind of off here is what at the end of week 1, maybe something like that. At the end of week 1, you have $3 and you decide to save $4 every single week moving forward. Okay. And then here, here's our context. So let me just copy this right here. Oh, wait, yeah. So here, I just want to come up with a context. So they already gave us a context. They said something about days and smiles. So you could say something like, I don't know, every every day you have been practicing your smile. You practice 7 times per day. On the, oops, not on the first day. On the first day, you forgot and only were able to practice 2 times. And then maybe the question would be something like, how many total smiles have you practiced? Write a function. There you go. Yeah. It's an awkward little context. I can come up with awkwarder ones if you don't know, but this was funny to me, so I just went with it. All right. So things that you need to know, you should be like, okay, well, where do I see the 7 in my context? That's right here. 7 times per day. Where do you see your 2, right? You should see your 2 right here. You only practice 2 times kind of thing. There's other contexts. This is not the only context, right? You can be like, your goal is to find 7 people who smile. I don't know. Maybe you're collecting data on people smiling. I don't know what they're doing. All right. So there you go. Hope that makes sense.